In this lesson, we'll be talking about the quote-unquote alternative tactics for the quantitative reasoning section of modeling and backsolving. So, quantitative modeling is just plugging in easy values. So, this is an alternative tactic for complex arithmetic, algebra, and word problems. You want to think about modeling as a possible tactic as soon as that algebra ceases to be apparent and simple to you in the moment. And this is a way you can avoid those engineer breaker complex technical manipulations. If you ever find yourself feeling like you need to factor a third degree quadratic on the GMAT focus, you probably don't need to. Instead, think about potentially quantitative modeling as an alternative tactic. Now, the clues for this tactic first are identifiable variables, assigned or unassigned. So they may actually be defined variables for the choices or the problem, or they may just be talking about a unknown number of marbles and not actually call it a variable. But those are going to exist in the choices and potentially the problem as well. You'll often have a word problem dictated by an unknown total. So again, like the total number of marbles in a bag or something of that nature. You'll also have the key terms, such as the phrase in terms of, or the literal words unknown or certain, because again, if I'm being asked about a certain number of widgets, maybe I could just define the number of widgets. So let's take a look at an example from a prior lesson that we could model as an alternative to the technical approach. So once again, we're going to set up the scratch pad, listing the choices vertically A through E. We are not going to write out these complex expressions as part of those answer choices, though, because they're relatively unnecessary to write out, and they don't really help without knowing what they mean. So then we skip to the end of the problem to identify the sought value, and we'd, of course, label the choices as the number of minutes for Callum to travel 10 miles. And we note the modeling opportunity clues here. We've got in terms of A and B. So that in terms of all of the variables in the answer choices and in the problem, even before I start reading from the beginning, I really want to have in mind that a modeling approach might work. So we see all of those terms, all of those answer choices with the variables, and we read from the beginning, taking simplified English notes as we go, because unless you're 100% certain of the algebraic approach and the algebraic expression even more directly, you don't want to try to build the equations as you go. It's actually how they can make it really hard to do. So we see Abby does 4 miles in a minute, so we just write something like Abby equals 4 miles in a minutes. It's not an equation, it's just a statement of fact. And Barry travels 2 miles in B minutes, so Barry equals 2 miles in B minutes. Then we've got the actual question, which of the following represents the number of minutes it would take Callum to travel 10 miles in how many minutes, as just a little, shorthand expression of that. And we know that it's at the average of Abby and Barry's rates. So we can plug in easy values for the foundation variable or variables that dictate the most aspects of the problem. In this case, what A minutes and B minutes are. You can also ignore reality to allow easy math. This is really important when you're plugging in. Don't try to make it realistic. It's like, how long should it take somebody to travel so long? Just make it so that the math is as simple as possible. So we're going to plug in some easy values, and we could very easily make A equal 8 and B equal 4. And that's going to make it so that there's none of our values that we're using here are in the answer choices, which is important because you don't want it to cancel out. So we don't want to use 2. But 8 and 4 are really easy because if Abby travels 4 miles in 8 minutes, I can figure out that that's going to be half a mile a minute. And if Barry travels 2 miles in 4 minutes, that's half a mile a minute as well. So because Abby's rate is half a mile a minute, Barry's rate is half a mile a minute, the average of their two rates is their two rates. It makes it as easy as possible. You do not need to make this complex. In fact, the entire point of the model is to keep it simple. So we know that the average rate is half a mile a minute. So Callum's time at half a mile a minute for 10 miles would be 20 minutes. Simple enough. So now we plug our values that we used of A is 8 and B is 4, seeking that target of 20 minutes. So we have 320. If we're dividing by 10 times A times B, that's going to be 320. That is way too big. And that's not what we want, because 8 times 4, 32, 32 times 10, 320, A and B are, we don't even have to work them fully through. We're like, that denominator is way bigger than the numerator, so it doesn't matter. When we look at choice C, well, then we just end up with 16. And you're like, that's not it either. We needed 20. You might have to test that just to make sure it's close enough to warrant fully solving, but it's definitely not the answer. Then we've got 10AB, which we've already established is 320. And we've got 2A plus B. So that's going to be 320 divided by 20, which is 16. Again, got the same answer, oddly enough, for both C and D, but still not 20. Whereas if we did 10AB or 320 divided by 2B, which would be 8 plus 8, so 320 divided by 16 is exactly the 20 that we sought for the number of minutes it would take Callum. And we could see that we really sidestep the complex algebra entirely here in this model. So as soon as the algebra got too wonky, and if you recall from our technical lesson a while back, that may have been tricky algebra to set up. Here, if you don't see the algebra, you could still solve the problem to the right answer using a good and easy model. So our modeling problem solving process. First, set up the problem, note the clues for the possible modeling opportunity. Variables or unknowns in the problem and or the choices, those phrases in terms of certain or unknown. A word problem that's dictated by an unknown value, often a total. In this case, it wasn't a total. It was the rates of these two other people and their average. And algebra, ultimately proving neither apparent nor simple to you in the moment. And that's just an honest assertion that you have to make on your own about what your skill level is with the algebra. Then step 2, pick an easy value for the foundation variable of variables dictating all aspects of the problem. In this case, it was the rates. Those easy values are going to be 2, 3, 5, 10, 100 and a half, or relevant factors or multiples. So that's why we used 8 and 4 there, because I was like, I could just make these rates be the same, so I don't even have to average them. They're just the same. And you will be able to think through this. The more modeling you do, the more skilled you'll become at building your model with easy values. But there are some values you want to avoid. You want to avoid 0, 1, any exact numbers in the choices of the problem. That's why we want to stay away from 10 or 2 in the last example. And also just any numbers that make hard math. The entire point of the model is to avoid hard math. So as soon as you find yourself having to deal with difficult math, just change your model's numbers. Then step 3, you work the problem with your easy value to reach one modeled solution. Change the numbers if at any point the math gets difficult. And then you plug your values into the choices seeking a match to the modeled solution. You have to test all 5 options to confirm there are no duplicate matches. Part of the reason that we avoid plugging in numbers like 0, like 1, like numbers in the answer choices is because they very often will end up canceling and giving you duplicate matches. So hopefully you don't encounter that many duplicate matches. But if you do, you're going to just have to change one value and retest. You can test only until a choice clearly does or doesn't match the model. So what that means is as soon as we saw like the denominators were bigger than the numerators, there's no reason to keep going there with the example that we just saw. You can change a value and retest if multiple choices match your model, and you stop testing and select when only one choice remains a match to your model. Now, let's talk about our other alternative tactic, and that's going to be quantitative backsolving or plugging in the choices. So this is also an alternative tactic for complex math and word problems. You can note the format of the choices again to identify a possible backsolving opportunity. And you'll also want to consider backsolving as an approach as soon as the algebra ceases, especially in a word problem, to be simple and apparent. So our clues for backsolving. First is going to be numbers in the choices in ascending or descending numeric order. It's just probably the clearest indication that you might be able to backsolve. You'll also often have a word problem seeking a single specific numeric value. You'll have some key terms too, such as how much, how many, and everybody's favorite, how old. So let's take a look at a problem-solving, back-solving opportunity. So we've got this little setup here. We set up our scratchpad, listing the choices vertically A through E, and because we've got real numbers in the answer choices, I definitely would want to write those out. We skip to the end of the problem to identify the sought value and label the answer choices as such. And in this case, we're being asked for what x is equal to. And we note the backsolving clues of the numbers in order from 0 to 4. So we can read from the beginning, taking notes as we go, and it's a pretty straightforward setup. We've got 5 to the x power minus 5 to the x minus 2 power is equal to 120. What is x equal to? So we first want to logically estimate to eliminate impossible choices. So here, I know that I'm subtracting something from 5 to the x and getting 120. And it has to be some sort of value that is positive for both of them. So what's ultimately happening here is I have to have a value for 5 to the x that is bigger than 120. So that allows me to eliminate A, which would be 5 to the 0 power, which is 1, B, which would be 5 to the first power, which is 5, and C, which is 5 to the second power, which is 25. Because all of those are going to result in something way less than 120 when you subtract something from it. So we eliminate A, B, and C immediately. Then we can just plug in the remaining middle or easier choice. And in this case, I'd probably go with 3. And when we do that, we get 5 to the third minus 5 to the third, 5 to the 3 minus 2, which is 5 to the first. 5 to the third is 5 times 5, 25 times 5, 125. And you subtract that 5 and you get the 120, and there's our correct answer immediately. So, setting up the problem, you want to note the clues for a possible back-solving opportunity. Those, of course, are going to start with single numbers in the choices in ascending or descending order. You're going to have those terms: how much, how many, how old. A word problem seeking a single specific numeric value, and algebra proving neither apparent nor simple in the moment. Then, step 2, you want to logically estimate to eliminate impossible values. Not saying that you could do this every time, but at least 50% of the time with back solving, you should be able to logically eliminate things by considering the circumstances of the problem to identify a reasonable range. And you also can assume that real life scenarios are likely to produce integer values. So, like if again they're asking for the number of marbles, and one of the answer choices results in you ending up with like a fractional number of blue marbles, that's not the right answer because the exam's not going to have a fraction of marbles. Then, step 3, we can plug in the middle remaining choice to work the conditions of the problem. You'll use columns to deliberately track the required steps. You'll set your final column as whatever the condition is that must be met. And then step 4 is only if necessary. You'll test the additional choices using the columns for organization. As soon as any choice matches all conditions, you can select it. So if that was your first choice, you're done. That's why this is only if necessary. As soon as a choice doesn't match, you want to consider whether that indicates that you need to go higher or lower in your ordered choices. And you can stop testing and select as soon as one choice remains, which means that if you've determined that you have to keep going lower and there's only one lower option, you don't even have to test that last lower option because it's the only thing that logically could work at that point anyway. So let's head on over to the whiteboard and take a look at how to use your scratch pad to execute these alternative tactics when you're working through the quantitative reasoning section of the GMAT Focus Edition. So here we've got a sample word problem. We're going to set up our scratch work. We've got A, B, C, D, E here, put a little line over top, and we're being asked if we skip to the end for the number of cards to start. And we've got real numbers, so I might as well write those out as well. So we got 75, well, 50, 75, 100, 200, and 400. And we note we've got numbers in the choices in increasing order and a how many. So that indicates a possible back-solving opportunity. Not saying you have to for any of these alternative approaches, but you just want to put yourself in a position to recognize that it might be viable. So we start reading at the beginning. We've got if Billy had 800 baseball cards to end last month. So end last month equals 800. And he has been building his card collection by doubling his number of cards each month for the 4 previous months. So each last 4 months equals double. How many cards did he have to start his collection? So at this point, I'm probably looking at this and going, you know what? It's been 4 months. It's impossible for it to be 400 to start because if you just doubled that, like 2 months, he'd be up to 1600. Same thing with choice D with 200. And if you started working through this, you quickly would recognize that this is a little bit of an engineer breaker because if I'm going to do this algebraically, I'm going to end up having to double it, and you're going to end up with like a weird quadratic that immediately happens. And I don't want to do that at all. There's no reason to make this that hard. But if we just say, thinking of our middle remaining choice, 75, cards to start. So we've got end month 1, then end month 2, end month 3, and end month 4. And that one's supposed to be equal to 800. And your last column should always be whatever the correct answer's condition needs to be. So cards to start, we've got end month 1 is going to double, so it becomes 150. End month 2 is going to become 300. End month 3 is going to be 600, and then I'm over. So on the exam, I'd go ahead and cancel out both of these and say they're gone. But just to prove it out, because I'd honestly just pick choice A at this point, we'd go end month 1 would be 100, end month 2 would be 200, end month 3 would be 400, and there's the exact 800 that we're looking for. And look how easy that is if you just go with the proverbial GMAT focused flow of, I don't need to do this technically. There's absolutely no reason to do so, in fact. And just set up some columns, work through the logic, and you can make a question into a really easy little evaluation through our backsolving approach. So let's take a slide down and we'll take a look at our second example here. So setting up our scratch work one more time, we got A, B, C, D, E, put a little line over top, and we've got real numbers again, so I'm going to write 2, and then I've got 2 and 2/5. I've got 2 and 1/2, got 3 and 5. So we're looking for the number of hours to knit, and we'll just say combo, because they're going to work together. So we know that starting from the beginning, Jane takes 4 hours. We know that M takes 6 hours. And we're going to assume that a single scarf can be successfully knit concurrently. So, assuming a constant rate here of 4 hours and 6 hours, what we can do at this point is, first, we can do a little bit of logical estimation, and that's always a good thing with these alternative tactics as well, because we know that if we had 2 Janes, that'd be equal to a total time of 2 hours. Logically, because you're like, okay, I double the amount of people, I'm going to have the amount of time. And if we had 2, M's for Marys, that would take 3 hours, which would be half of the 6 that Mary takes alone. So we know that the J and M combo has to be between 2 and 3 hours, just based on some simple logic. So that allows us to basically get down to B or C on that level alone. And remember, always be looking for logical estimation and evaluation opportunities at every step of every problem. Now, let's think about this with a little bit more detail in the model. Let's say, we'll say that it's just an easy value that we can take as like the square feet. I'm not entirely sure how a scarf works, but in terms of like measuring it. But let's say that a total scarf is equal to, we'll go with 24 square yards. So that means the J rate is going to be equal to 6 yards per hour, because you just have takes are 4 hours, so 6 times 4 gives me my 24. My M rate would be equal to 4 yards per hour. So again, you can see that structure. You're like, okay, 24 divided by 4 means 6 hours. And 6 hours times 4 yards per hour gives me my 24 yards per hour. So their combined rate in this model would be 10 yards per hour. And so then we know that time is equal to my work, or 24, divided by the combined rate we just found, which is 10, which is going to be 2.4 hours, which is equal to 2 2/5 of an hour, which gives us our correct answer of choice B. So you can see through these alternative tactics, there's a lot of opportunities for efficiency and accuracy outside of the normal technical structure. So as you're working through your next drills and all of your drills moving forward for the quantitative reasoning section of the GMAT focus, make sure you're considering all tactics at all times for the best approach for you as you move through your practice towards an ultimate test date.